Hi everyone, so in this video we're going to talk about contrapositive. So once again, kind of like converse, contrapositive, we really only talk about it when it comes to implications. Okay. So the contrapositive of P implies Q is, well, first we're going to flip-flop them. Okay, so we have Q implies P, but we're also going to negate both P and Q, okay? So here's where the fun comes in. These are logically equivalent. Okay, so an exercise is to convince yourself of this with truth tables, okay? So if we prove the contrapositive of a statement, meaning an implication, then that is logically equivalent to proving the original statement, okay? So let's say I want to prove P implies Q, but I'm looking at it and I'm like, well, it might be easier if I show that not Q implies not P. Well, lucky for me, they're the same. They're logically the same. So I can prove that, and it's the same as proving the other thing. Okay? So you can think of it as if it's a direct proof, but the contrapositive of the original implication. So you do the front work in the beginning and you figure out what the contrapositive is, and then you just do a direct proof from there. Okay? It's not like contradiction way of proving things where you assume something and then you got a gotcha somewhere. Okay? This one should not have any gotchas because you're trying to show that it is true. So here's an example of something that, at least for me personally, I feel like the contrapositive seems a lot more approachable to prove than the original. So first, let's actually talk about what the contrapositive is going to be. Okay, you could pause this if you already feel confident. You can pause this and try to figure it out on your own. Okay, so I have this part and then I have this part. Okay, so first I'm going to flip them. So I have A minus B equals A to here. A intersect B equals the empty set. Okay, but I'm supposed to negate both of them. So remember, negation, we're not like changing the sets that we're working with. We're just saying it's not the original thing. So it's not the fact that A minus B equals A. So what does that mean? That means that A minus B does not equal A. Similarly over here. Okay, so this is the contrapositive. So this is the only example I'm going to give today. So if you do want more examples, just let me know, and then I can make another video or something. Okay, so let's start the proof. So now, like I said before, basically how I'm going to approach this is I'm just looking at this, and I'm doing a direct proof of that. Okay, proof. Okay, so I'm going to assume the if part is true. All right, so what does that mean for these two sets to not be equal? It means that one of them must be a strict subset of the other. Or just have nothing in common. That's also a possibility. But they do have something in common. If you take a second look at them, we have A minus B and A. So by definition, A minus B is always a subset of A. Okay? Whether you're minusing A, you're minusing the empty set, you're minusing something that even has elements outside of A. Remember, we only pay attention to the ones that are in A. Because A minus B are all the elements in A such that those elements are not in B. Okay? So it's always going to be a subset of A because where are we grabbing them from? They're going to be elements of A. Fabulous. So since they're not equal, we can't have subsets in both directions. Okay, so that means that A is not a subset of A minus B. So what does that mean? That means there's an element in A that's not in A minus B. So that means that A minus B is a strict subset of A. Okay, so what does it mean? Well, we just kind of talked about it. There exists some X in A such that X is not in A minus B. And maybe let's rewrite what that set is, just to help us remember. So it's all the elements X such that X is in A, but it's not in B. if x is not in a minus b, it must not satisfy something over here. X is in b. Here, I'll do a little more explaining. Or else x is in a minus b since x is in a. Okay? So now we've shown that x is in a and x is in b. Then by definition, it's in the intersection of a and b. So now x is in the intersection of a and b. All right. So now here's the point where I'm like, wait, does this even matter? Because you can always just like start saying true stuff, right? But that doesn't always mean you're moving in the forward direction. Okay, so what the heck am I trying to do? Well, I'm trying to show that A intersect B is not the empty set. Oh, sweet. I just showed that there's an element in the intersection. Therefore, A intersect B is not a subset of the empty set. Okay, so remember, the empty set is always a subset of any set you talk about. Okay, but now we have that A intersect B is not a subset of the empty set, meaning A intersect B not equal to the empty set. So another way you could say this is you could say that the empty set is a strict subset of A intersect B. That's another thing you could say. Because you always know that the empty set is a subset, but now we know it's a strict subset. Okay, so now the conclusion, we want to talk about how we use the contrapositive. Wow, if I had a nickel every time I said therefore. Therefore, the contrapositive is also true, that A intersect B equaling the empty set implies that A minus B equals A. Okay? Because if we remember back to the beginning, if you take the contrapositive twice, you just end up back where you were, right? Because so you flip, and you flip back, but you also negated both of them, and then negated them again. But if you remember, back when I first introduced negations, I think it was in that first video, we know that if you negate something twice, it's the same as the positive, same as its original. Okay? All right, and so why I'm not giving a whole lot of examples for this one is because it's basically the same proofs as you already know, because it's just direct proofs. It's more just a definition thing of knowing what the contrapositive is. So me not going over it too much is not an indicator that it's not important. The last thing that I wanted to mention is, so you see it's very important, proof by contradiction can be used on any kind of statement that you want. An and statement, an or statement, just a statement standalone, but a proof that uses contrapositive can only be used on an if-then or an implication statement.